This is a video to investigate limits and continuity by looking at a graph. The question states, use the graph to determine where the limit is undefined and where the function is not continuous. So I'm going to start by looking at the graph a little bit larger. And let's start with where we have an undefined limit. I'm going to move from left to right and investigate where I don't have a limit. So if I start out here, I go along the curve and I'm just fine. As long as it's smoothly moving along the curve, you're okay. But then as I get towards x equals -2, I see I have a vertical asymptote. We're going off to negative infinity and then we're jumping up to positive infinity. So my first point where I have an undefined limit is at x equals -2. Okay, now I'm going to continue on from left to right. And I move, I'm smooth, I'm doing fine. Then I get to the point x equals 1, and I notice that I jump at x equals 1 from way down here to jumping up to here at y equals 3. If we have a jump like that, that's going to be an undefined limit. So that's our next number. X equals +1 is a point at which we have an undefined limit. So now let's continue on from left to right, and I move here and I have a hole. Well, it turns out because I have a hole does not mean I don't have a limit, because if I move from left to right or right to left towards that point, you'll notice that my y value is approaching that same number, in particular y equals 2. So this does have a limit at x equals 3. I don't have to place that under my list of undefined limit numbers. So let's continue on. And I move along until I get to x equals 4. Then I can see I have another jump. In fact, it goes from here x equals 4, and then I have an asymptote on the right-hand side. So there's no limit. The left and right do not meet. So that's my next number at which I have an undefined limit, x equals 4. So now continuing on, you'll notice for the rest of the graphs, it just smoothly goes along the curve. No problem. So now let's look at continuity. One thing with continuity is if the limit doesn't exist, the function is not continuous. So right away, the limit doesn't exist at -2, 1, or 4. So all three of those numbers have points of discontinuity. X equals -2, x equals 1. And then notice that when we get to that hole, when we do have a hole, we say that the function is not continuous. If we move along the curve, we have to lift our pen up to get to the other side, and that means it's not continuous. So we could say that the function is not continuous at x equals 3. So there's x equals 3, and then we also had x equals 4. We didn't have a limit, so it's not continuous. And then we continue on. The rest of the way is nice and smooth, so it's continuous the rest of the way. So the list of undefined limits is x equals -2, 1, and 4. And the list of discontinuities is that x equals -2, 1, 3, and 4. And I'm done with the problem.